everyone, Simi here. I'm excited to announce an upcoming multi-agent-based development course for senior GenAI folks, led by the brilliant Avinash Mishra.
All right, let's jump right in. Today we're going to talk about one of the biggest and honestly most important steps for any developer, how you take a project that works perfectly fine on your laptop and turn it into a real-world application that's ready for launch. So what's really the difference?
You know, it all boils down to this single question. It's not just about getting the code to run. It's about making it configurable, making it fast, secure, and totally reliable, no matter where it's running. This is the real journey we're talking about, from a simple prototype to a rock-solid production-grade service.
First up, let's tackle one of the most common mistakes I see, and that's making your app adaptable. Look, your laptop is a friendly, predictable place. A production server? Not so much. Your code needs to be able to handle any environment you throw at it, without you having to rewrite it every single time.
Oh man, we have all done this. You get your database connected, and you just slop the URL right there in the code. Hey, it works, right? So you move on. But this is a ticking time bomb. What happens when you need to deploy to a staging server or to production? And even worse, you've probably just committed passwords and secret keys right into Git. That's a massive, massive security no-no. The fix, thankfully, is actually pretty simple. So check this out. On the left, you've got that rigid, inflexible code. It's hard-coded, it leaks secrets, and it's a pain to manage. But on the right, that's the smart way. The code doesn't know the database URL. It just knows to ask the environment for it. This is a game changer, because now the exact same code can run anywhere, and your precious secrets are kept completely separate.
And this whole idea has a name. It's called externalized configuration. And let me tell you, it is a non-negotiable, foundational principle for any serious backend app. It doesn't matter if you're using Spring profiles in the Java world or .env files with Python or Node, the goal is always the same: separate your code from the configuration. Getting this right is your first huge step toward going pro.
Okay, so your app is all configured. It's up and running in a new environment. But, real people are starting to use it, and things are getting kind of sluggish. So let's move on and figure out how to beat the next big boss, the performance bottleneck.
So here's a super common performance trap. Every single time a user makes a request that needs to talk to the database, your app dutifully opens a brand new connection. This whole process, the network handshake, the authentication, it's actually really slow and resource intensive. Now imagine hundreds of requests coming in every second. Your server and your database are just going to grind to a halt, totally overwhelmed by just opening and closing all these connections.
The solution here is something called connection pooling, and it's brilliant. Think of it like a valet service for your database connections. Instead of your app building a brand new connection from scratch every time, it just goes to a pre-warmed pool of connections and says, hey, can I borrow one? It gets one instantly, does its work, and then returns it to the pool, ready for the next request. This recycling is a massive, massive performance win.
So, we've made connecting to the database way more efficient. That's great. But connection pooling doesn't really help if the database queries themselves are slow, or if we're just hammering the database for the exact same data over and over and over again. So how do we reduce the database's actual workload?
The answer, of course, is caching. And you've basically got two main flavors to choose from. For a simple app running on a single server, a little in-memory cache is perfect for stuff that doesn't change often. Think a list of US states or country codes. But if you're building a big application that's scaled out across many servers, you need a distributed cache like Redis. It acts like a shared, super fast memory bank that all your app instances can talk to. This keeps your data consistent and your response times lightning fast.
Okay, we're making serious progress. Our app is now configurable and it's fast. But before we can actually launch this thing, we have to deal with the final and maybe most critical challenges: making it secure and making sure it runs the same way everywhere.
This is the million-dollar security question, isn't it? We already know we can't put secrets in our code. And using environment files is better, but you definitely shouldn't be committing a file called .env.production into your source control. So where in the world do these incredibly sensitive credentials actually live?
The professional solution is a dedicated secrets management system. Think of things like HashiCorp Vault or AWS Secrets Manager. You can literally think of it as a digital vault for your application secrets. Your app gets temporary, highly restricted permissions to retrieve the secrets it needs when it starts up, and nothing is ever stored in plain text anywhere in your code base or on a developer's machine. For production systems, this is absolutely not optional.
We are so close. We've reached the final hurdle. You've done all this amazing work. You hand your code off to the deployment team, and they come back and say it's broken. You know the line. But it works on my machine. How do we finally put that problem to bed for good?
The answer is containerization, and the undisputed king of containerization is Docker. The best analogy I've ever heard is that it's like a magic shipping container for your code. Think about it. It doesn't matter if a real shipping container holds cars or bananas, it can be moved by any standard crane, ship, or truck. Docker does that for your code. It bundles up your application, all its libraries, and its configuration into one standard, isolated box that will run the exact same way on your laptop, a testing server, or in the cloud. It's a true game changer.
You know, we've covered a ton of ground here. Configuration, connection pooling, caching, secrets management, containers. But it's really important to understand that these aren't just a random collection of tips and tricks. They're all pieces of a much larger guiding philosophy for building software.
That's right. These practices aren't just things that are nice to do. They align your work with a battle-tested, proven blueprint for how to build modern applications that are designed from the ground up to be scalable and reliable.
And that blueprint is called the 12-factor app methodology. Everything we just talked about maps directly to its core principles. Remember how we separated our configuration using environment variables? That's factor number 3, config. Treating our database as an attached resource that we connect to via URL? That's factor 4, backing services. And those self-contained, robust apps we build with Docker? That's what principles like port binding and disposability are all about.
So there you have it. We've done it. We've architected an application that's configurable, performant, secure, and easily deployable. It's truly built to last. But this brings up the next big question in any application's life, doesn't it? Once it's out there, running in the wild, how do you actually know if it's healthy? How do you monitor it? That's a huge topic and maybe one for another day, but it's the final piece of the production-ready puzzle.
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.
We rely on our digital services for pretty much everything these days, right? Especially our banking. So today, we're going to pull back the curtain and ask, what is really going on behind that screen? We're diving deep into what happens when those services break and the absolutely crucial practice that keeps them up and running. Okay, picture this. You've got to make an urgent, super time-sensitive money transfer. You hit the send button, and you get an error. Nothing. No reason why. It's frustrating, it's kind of stressful, and boom, your trust in that app just took a major hit. The question running through your head isn't just what happened, it's how are they going to fix this, like right now? Now, let's flip over to the engineer's side of the screen. For them, a modern banking app isn't just one simple program. Oh no, it's this massive, complex web of interconnected services. There's one for accounts, another for transfers, one for logging in. You get the idea. So when your transfer fails, the cause could be hiding literally anywhere inside this thing. From the outside, it is a total black box. So, how in the world do you fix a problem you can't even see? Well, you have to find a way to turn on the lights inside that black box. And that's where the key idea for today's explainer comes into play. It's called observability. And it's not just some tool you can buy. It's more of a capability, a way of thinking. It's all about designing your systems from day one to be transparent. The goal is to turn that mysterious black box into a crystal clear glass box, where engineers can see exactly what's happening inside and find the root of a problem in real time. So to build this glass box, engineers really lean on 3 core pillars. Let's kick things off with the first one, which you can kind of think of as the system's own super detailed detective's logbook. Remember that complex banking app with all its different parts? Well, every single one of those little services is constantly writing down notes about what it's doing. We call those logs. Centralized logging is the practice of gathering every single one of those digital footprints from all over the system and pulling them into one searchable place. So instead of clues being scattered all over the crime scene, you get the whole story right there in front of you. But how those logs are written, man, that makes all the difference. See, a plain text log is just a messy jumble of words. It's really hard for a computer to search through. But a structured log, that's a game changer. Everything is neatly labeled. You've got user ID, transaction ID, everything. This format is built for machines, which means an engineer can sift through millions of events in seconds to find the one single event that matters to you. And this is what that actually means for you as a user. This isn't just some technical jargon. Good, structured logging is the reason a support engineer can instantly find your specific failed transaction, trace its journey through the system, and see exactly where things went sideways. It means faster customer support, better service, and a crystal clear audit trail for security. Okay, so logs are great. They tell us what happened in one specific event. But what about the overall health of the entire system? For that, we need our second pillar. And this one acts like a continuous medical checkup, always monitoring the system's vital signs. These vital signs are called metrics. They're basically just numbers measured over time. So if a log is like a detective's note about a single crime, a metric is like the system's heart rate or its blood pressure. It tracks those high-level trends, telling engineers how much is happening and how often. Let's take login attempts, for instance. Engineers can look at a chart like this and see, at a glance, how many people succeeded versus how many failed in the last hour. If that failed bar suddenly shoots through the roof, they know something is wrong. Maybe a login service is down, maybe there's a security threat, long before tons of users start calling in to complain. So you can see how they really work as a team. Logs are the detective, digging into the nitty-gritty of what happened in one specific case. Metrics are the lookout, perched up high, spotting the big trends and seeing how much is going wrong. An engineer will see a spike in a metric to know that there's a problem, and then they'll dive into the logs to find out exactly why. They're a perfect pair. Logs and metrics are fantastic for investigating, for sure, but we don't want to wait for an engineer to just happen to notice a problem on a dashboard. We need an automated way for the system to basically cry for help the second it's in trouble. And that brings us to our third and final pillar. This whole thing starts with something called a health check. It is so simple, but so powerful. Basically, an application creates a special web address, like /health, and other systems can check it. It's like being able to just walk up to a service and ask, "Hey, you okay right now? You ready to do some work?" And here's how it works. An automated system is constantly pinging that health address. The application then does a super quick check on its own critical parts, like making sure it can talk to its database. Then it just replies with a simple status okay, or if something's wrong, status unhealthy. That way, the rest of the system knows not to send any more work to the part that's struggling. So what happens when a health check does fail? Or when a metric crosses some dangerous line? You can't just have that information sitting there. That's when alerting kicks in. It's an automated system that immediately fires off a notification, an email, a text, whatever it takes, directly to the on-call engineering team, telling them something is broken and it needs their attention now. So there we have it, our three pillars: logging, metrics, and alerting. When you put them all together, they create this incredibly powerful system of observability. But you know, this isn't just about technology. It's about something way more important, especially when we're talking about banking. It's about building trust. Ultimately, this is why observability matters so much. It ensures that the system is reliable, especially when you need it the most. It allows engineers to solve problems with incredible speed, which protects your sensitive financial data. All of this works together to build and maintain your trust as a user. It gives you the confidence that the bank takes the health of its systems and your money very, very seriously. Because in today's digital world, a bank's ability to see and understand its own technology is directly tied to its ability to protect its customers, which really just leaves us with one final and pretty crucial question. If an institution is flying blind, operating in the dark, should you really be trusting it with your money? Thanks for joining us.
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.
Hey everyone, and welcome! If you've ever been curious about what the cloud actually is, or how all these amazing modern apps get built, well, you are in exactly the right place. We're going to dive in and really demystify the foundations of Amazon Web Services.
I mean, really think about it for a second. You pull out your phone, you tap on an app, and it just works. Instantly. Doesn't matter if you're in New York, Tokyo, or London. How does that happen? How can a brand new company get their idea out to millions of people seemingly overnight? Well, the answer, a lot of the time, is a platform like this one, Amazon Web Services, or AWS for short. It's this incredible, massive, global infrastructure that lets anyone, from a solo developer in their garage to a huge global enterprise, build and launch applications with unbelievable speed and scale.
Okay, so let's start at square one. What on earth are we even talking about when we say the cloud? Is it, actually in the sky?
It really is this simple. Instead of going out and buying your own expensive physical servers and all the stuff that goes with them, you just rent them. You access all the IT resources you need, computing power, storage, databases, right over the internet from a provider like AWS. And the best part? It's pay as you go. You only pay for what you actually use, kind of like your electric bill.
And when I say resources, I'm not kidding. We're talking about a ton of them. AWS has over 200 fully featured services, so this isn't just one thing. It's a gigantic collection of digital tools that you can piece together to build just about anything you can dream up. So, with over 200 services, where do you even start, right? Well, the best way to think about it is like a digital toolkit. You don't need every tool at once. You just grab the right tool for the job you're trying to do. So let's look at a few of the most essential ones. First up, we've got the absolute workhorse of the cloud, Amazon EC2. The easiest way to wrap your head around this is to picture it as your very own virtual server that lives in the cloud. It's a machine that you set up and it can run your application 24/7. It's pretty much the foundation for a huge chunk of the modern internet.
But what if you don't need a server running all the time? What if you just need a little piece of code to run whenever a user, say, clicks a button on your app? Well, that's where AWS Lambda comes in. It's what we call serverless, which basically means you just upload your code, and AWS takes care of all the rest. It literally only runs when it's needed. And this right here really clarifies the difference. Think of it this way. An EC2 server is like owning a car. It's yours, it's always there in the driveway, ready to go. But you're responsible for the gas, the insurance, the oil changes. A Lambda function, on the other hand, is like calling a taxi. It shows up exactly when you need it, takes you exactly where you need to go, and then it's gone. You don't have to worry about the engine at all.
Of course, an app is more than just code running, so your toolkit also has other essentials. There's S3 for storage, which is like having a bottomless digital filing cabinet for all your data and files. Then you've got IAM, which is like your app's head of security, handing out keycards and deciding who gets access to which part of your system. And finally, CloudWatch, which is your dashboard, letting you monitor the health and performance of everything to make sure it's all running smoothly.
All right, that's enough theory. I think we can all agree the best way to really understand these tools is to actually build something with them. So let's take a look at a really cool hands-on project that brings all these concepts to life. We're going to build a simple, two-part application, a mini bank. Now, this is great because it gives us a really concrete goal and lets us see exactly how these different AWS services have to work together to create a real product. And don't worry, this isn't nearly as complex as it might sound. The whole project is broken down into 4 clear, manageable steps. We'll start with a quick tour of the main control panel, then we'll build the 2 main parts of our app, and finally, we'll set up some monitoring to keep an eye on it. Easy enough? Okay, now for the really cool part. Let's see how that digital toolkit we just talked about is actually used to put this mini bank together piece by piece.
So this is where it all clicks into place. This shows you exactly how you pick the right tool for the job. Our core balance service, that needs to be on all the time, ready to handle transactions at any moment. That's a perfect job for our EC2 virtual server, our always-on car. But the account status checker, that only needs to run when a user actually asks, hey, what's my balance? That is the perfect job for our on-demand Lambda function, our taxi. And you see, this isn't just a tech decision, it's a smart business decision, because you're not paying for a server to just sit there doing nothing.
So we've seen the concepts, we've looked at the tools, and we have the plan. What does it actually look like when you put it all together? You know, how fast can you really go from just an idea to a real working application in the cloud?
1 hour. That's it. In about the time it takes to watch an episode of your favorite show, you can go from absolutely nothing to a fully deployed, multi-part cloud application. I mean, that is the real power of the cloud. It just shrinks the time and effort it takes to bring your ideas to life.
And that is just an incredible feeling. You haven't just learned about something, you've actually built something. You've created a working application using the exact same powerful tools that run some of the biggest companies in the entire world.
So the big takeaway here is really that journey we just went on. We started with a super simple definition of the cloud. We opened up the AWS toolkit to look at a few key tools, and then we saw exactly how those tools snap together, just like building blocks, to create something real and functional.
And that really is the final and most important question, isn't it? Now that you understand these fundamental pieces, the virtual servers, the serverless functions, the storage, the possibilities are, well, they're kind of endless. The toolkit is officially in your hands. So, what are you going to build next?
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.